Dart is object oriented, and we'll look at the concepts around object orientation before we dive deep into the examples. Object orientation is an idea in coding that organizes software design around data objects rather than functions or logic. So the key concepts we have in object orientation are classes, methods, objects, and attributes. We'll look at examples of what each mean. What is a class? It is a blueprint of some sort that defines the design of so-called objects. It allows us to think of concepts as objects with data as states and interfaces or methods to allow data manipulation. A class has three main things: variables or attributes, properties, and methods. We'll look at interfaces in Dart. What is the importance of an interface? One is to achieve abstraction. The second way is to achieve multiple inheritance in Dart. Some important points to keep in mind when looking at interfaces include: if a class has been implemented, then all of its method and instance variables must be overridden during the interface. In Dart, there are no direct means to declare interface, so a declaration of a class is itself considered as a declaration on the interface. A class can extend only one class but can implement as many as you want. We'll look at a practical example of an inheritance structure. The root of the hierarchy will be animal. Extending the animal will be bird and human. Doctor will extend human. We will also look at various methods that each of the inheritance hierarchies will contain. Let's implement the inheritance structure that we just saw in the diagram. Here we have an animal class with a name, which is a string, a classification, and a constructor to the animal class. Let's create the first class that inherits the animal. We call it bird. Let's give bird a few properties. We add a boolean property called has wings. The bird constructor will accept a name and a default parameter called has wings set as true. And note that we have the super, which refers to the animal class. The name and the classification are passed to the bird class, and note that the classification here is the enum that we just declared at the bottom, one of the enums rather, the bird's enum. We'll create the instances of bird here. To create bird, we need to pass in a name and an optional parameter if you want to change the has wings. We do not need to pass in a classification when creating a bird because we call the super constructor and pass in the classification.birds. Here we create an instance of bird called Henry. We pass in the name as ostrich, has wings as false. This has wings indicated is the default parameter, but we are overriding this on line 2 and passing in a false value. Here we quickly just refactor it to does fly. It's a lot easier to read. Next up, we create another instance. We pass in the name as lovebird and the variable name as Peggy. Note that we pass the does fly as true by default, so Peggy will have it is true. Here we create another another class called human that extends animal. We have a variable gender, and we'll create a quick enum, male and female. So we need to create the constructor here for human. We'll pass a string, we'll create the parameters as a string name, a gender, and we'll pass in the classification as mammals. Up next, let's create another one called doctor, which extends human. So this is second in hierarchy. We create another quick enum called doctor type. Note that we do not need these enums. These are just to make our code more readable and just to bring more clarity and make this example practical. So doctor would be very similar to human, except in this case we now have a doctor type that differentiates the doctor class. Great. So let's add another variable called distance moved to the animal class. By default we assign this as 0.0 if it is not passed. So what we will do here is we'll create another method called move in bird, and let's just say that when move is called, we're gonna change the distance by 5.0. In humans, we change the distance by 1.0. So let's create another quick instance of a human. Let's name the variable David. Human needs a string and a gender. We will pass David as the name and the gender enum. Let's just pass a male for now. And let's try printing Henry, Peggy, and David. These are the three objects. Note on the right hand side we have the outputs. Currently our outputs are not what we expect. Therefore we can create an override method in any of the classes in order to refine our print. So we can simply return a print statement that we would like in the toString method. The toString method comes by default with every class, and it's simply the method that is called when we call a print statement in the main function. So here in the main function, let's try and call the move function on each of the objects. The move function will change the respective distance moved. So here we now see a different console output. It's mostly because we modified the print statement. Let's quickly add like a delineator so that we can clearly see the before and after. When we call move, that's the before, and that's the output after. Up next, we can create another class. Let's just call it an unknown class. Simply add a quick enum called unknown in the classification. The constructor is what we just discussed. Pretty straightforward. Let's try creating an instance of unknown. Our instance is called some random, and let's just say, let's also add another method to our animal class called move. This is similar to the method that we had added to the other classes before, except now the parent, the root animal class, has the move function. Reason for this is some random, which is an object of type unknown, does not have the move function, but it will inherit the move function because it is of type animal. You can see on the right hand side that the object of unknown type does have a distance moved as 0.5, which is similar to what we had put the function as in the animal class. So you can see that the bird function sort of complains there's a warning, and this is because we need to add the override annotations to both bird and human classes, because we override the original parent function called move that we later added in animal class. So this is the inheritance we had implemented. Let us now look at a practical example. Pause the video after the question is done if you have to. This is a practice example built on the first example. So let's try and create an additional class called reptile, which extends the animal class, and then we add another class called crocodile, which is under reptile. We also want to add a property called number of teeth in the animal class, and let us try creating an instance of it in the main class.